Hello grade 11 students. Today I am here to teach you geometric progressions in your textbook, that's in chapter 16. In grade 10 we discussed about arithmetic progressions. What are arithmetic progressions? Set of numbers with constant difference. For example, we can take 3, add 4 to that, you get 7. Add 4 to that again, 11. 11 plus 4, 15. So here 3, 7, 11, 15 are the terms of arithmetic progression. Why? The difference between two consecutive terms is plus 4. That's a common difference. So we discussed before about common difference. D for arithmetic progression. Ordered set of numbers with common difference. If I know any term here, you can find out the next term, because if this is arithmetic progression, we can add 4 to that to find out the next term. But if we take triangular numbers, what are triangular numbers? One, 3, 6, 10, 15. Those are triangular numbers. What we can say about the difference? Here we are adding 2. Here we are adding 3. We are adding 4 like that. This is a sequence or a progression, but it's not arithmetic. So if we know any term, we can't find out the next term because we don't know how many we need to add to get the next term. So something like this progression, you can't use the common difference. Now we'll see what are geometric progressions are. So geometric progressions are set of numbers, set of ordered numbers with common ratio. So here ratio means multiplication. Think about this example. 3 multiplied by 2. 3 times 2, 6. Multiplied by 2 again. 6 times 2, 12. Multiplied by 2 again. 12 times 2, 24. So these are called geometric progression because you multiplied any term by a constant ratio. Here, what's the constant ratio? Multiplied by 2 to get the next term. So here 3 multiplied by 2, you get 6. 6 multiplied by 2, you get 12. So this is called geometric progression. Now, how we can find out the common ratio? Common ratio we can easily find out by taking any term, divide by its previous term. So in this example, we'll start from here. Any term, 6. divide by the previous term. You get 2. Any term 12, divide by its previous term. You get 2 again. When you take this term, 24, divide by the previous term, you get 2. So here we see always the ratio is 2. So that's why we call it's a common ratio. And if you take the next term, how can we find out? If you know the common ratio, if you know the term, then just multiply by the ratio to get the next term. So here in geometric progression, remember, you get a common ratio. We can denote this common ratio using a letter, that's R. In arithmetic progression, we use D. D is the common difference. Now we are using common ratio as simple R. If we know any consecutive numbers easily, you can find out the common ratio. Now we'll take these examples and find out the common ratio of the following GP. So GP stands for geometric progression. Take the first one, 7, 14, 28. So here, how can we find out the common ratio? Take any term. If we take 14, divide by the previous term, that's 7. Or if you take 56, divide by 28. You can take any term, but it's easy to take the easiest one. So 14 and 7, we know that's 2. So the ratio, common ratio is 2 in this example. Now take the next one. How you can find out the common ratio? Take any term. I'll take 9, divide by the previous term. 9 divided by 3, you get 3. Or 81 divided by 27. Or 27 divided by 9. This one, find our any term, divide by this. So here, I'll write this way. 1 over 4 divide by half. Rather than writing two fractions in the numerator and the denominator, I'll write this way. So it's easy to find out the answer. 1/4 divide by half. So 1/4 multiply by the reciprocal. So what's the answer? You get half. Half as the ratio. If you want 1 over 16, divide by 1 over 8. You get the same answer. This one, any term, I'll take 32, or here, if you take this side, it's easy to simplify. Any term, divide by its previous term. 8 divided by 4, you get half. So that means multiply by half. Any term multiplied by half, you get the next term. This one, which one is the easiest to find out the common ratio? This one. If you take this one, you get fractions. So here 54 divide by 36. So here when you divide by 18, 18 times 2, 18 times 3. So the ratio is 3 over 2. Look at these examples. Now you get surds also. But easy to find out the common ratio. What's common ratio? Take any term, divide by its previous term. I can take this one easily. 3 root 3 divide by 3. 3 get cancelled out. I get root 3. This one, what's the common ratio? So 7 divided by minus 7 or minus 7 divided by 7. You get the same answer. Minus 1. This one. This is the easiest one. 0.1 divide by 1. You get 0.1. This one, which one is easy? When you get fractions, it's easy to write this way. Any term half divide by previous term 1/4. Then I can rewrite this as multiplication with the reciprocal. When I take reciprocal, I get ratio as 2. What it means? Take the term, multiply by 2 to get the next term. 1/4 multiplied by 2, you get half. This one, what's the ratio? Common ratio. Take any term, divide by its previous term. You get x as the common ratio. Now this one, write down the first 5 terms of the following geometric sequence or geometric. I can write progression. Same meaning. Progression or sequence. First term, I'll take first term as A. First term is given and the common ratio is given. So how can we write down the sequence? We need first 5 terms. So starting from 5. 5 times 2, 10. 10 times 2, 20. 20 times 2, 40. 40 times 2, 80. So we have 5 terms. Starting from first term 3. Common ratio is minus 2 now. Multiply. 3 times minus 2, you get minus 6. Minus 6 times minus 2, you get plus 12. Plus 12 times minus 2, minus 24. Minus 24 times minus 2, you get plus 48. 1, 2, 3, 4, 5. We have 5 terms. This one, first term is 2, starting from 2. What's the next term? Ratio is 3, 2 times 3, 6. 6 times 3, 18. 18 times 3, 54. 54 times 3, 162. 1, 2, 3, 4, 5. So we have 5 terms. This one, starting from 243. 243 multiplied by 1/3 means you divide by 3. When you divide by 3, what you get? We get 81. 81 divided by 3, 27. 27 divided by 3, 9. 9 divided by 3, you get 3. 1, 2, 3, 4, 5. So those are the 5 terms when it's A is 243 and R equals 1/3. Take these examples. Now you get fractions. Starting from 1/3. Multiplied by half. 1/3 multiplied by half. 1/3 and half becomes 1/6. That means actually the denominator multiplied by 2. 1/6 times 1/2, you get 1/12. 1/12 times half, 1/24. 1/24 times half, you get 1/48. This one, starting from 48. The ratio is 3/2. Now, you can't do at once. So, best thing is to do it separately. 48 multiplied by 3/2. What's the answer? You get 24 multiplied by 3. 3 times 4, 12. 1 remaining, 3 times 2, 6 plus 1, 7. So 72. 72, another 3 2's. So here 72 multiplied by 3 over 2. You get 36 times 3. 36 times 3, 3 times 6, 18, 1 remaining, 3 times 3, 9 plus 1, 10, 108. 108 multiplied by 3 over 2. 54 multiplied by 3. 3 times 4, 12, 1 remaining, 3 times 5, 15 plus 1, 16. 162, we need another one more term, 162 into 3 over 2, you get 81 multiplied by 3, 243. This one, A is x, that means the first term is x, starting from x. Ratio is 3, 3 times x, 3x. 3x times 3, 9x. 9x times 3, 27x. 27x times 3, 81x. This one, starting from 3. The ratio is now x. 3 times x, 3x. 3x times x, 3x squared. 3x squared times x, 3x cubed. 3x cubed times x, you get 3x to the power 4. This one, the first term is a. So starting with a. The common ratio is b. A times b, ab. ab times b, ab squared. ab squared times b, ab cubed times b, ab 4. 1, 2, 3, 4, 5. So those are the 5 terms. This one, starting from a, the common ratio is m. A times m, am. am times m, am squared. am squared times m, am cubed times m, am to the power 4. Starting from x, the common ratio is y. X into y, xy. xy times y, xy squared. xy squared times y, xy to the power 3. And again, when you multiply by y, you get xy to the power 4. So, if you know the first term and the common ratio, you can find out the geometric progression. Look at example number 1. Check whether the number sequence 2, 6, 18, 54 is a geometric progression. How can we identify a geometric progression? We need to get the common ratio. When we take 2 consecutive terms, if we get the same ratio, then we can say that's a geometric progression. So we can check 6 with 2, you get 3. 18 with 6, 3. 54 with 18, that's also 3. So the ratio, we get common ratio of 3. So therefore, it's a geometric progression. When you have given something like this, you need to check all terms. Example number 2, check whether the number sequence this is a geometric progression. Starting from here, any term divide by its previous term, you get half. 50 divided by 100, you get half. 20 divided by 50, do we get half? No, this time you get 2/5. So you are not getting common ratio. No common ratio. Therefore, not a geometric progression. Example number 3. Check whether the number sequence 5, 10, minus 10, 20, minus 40, 80 is a geometric progression. So what's the first step? Take any term, divide by the previous term. First I'll check the first and second terms. Minus 10 divided by 5. You get minus 2. 20 divided by minus 10. Minus 2. Minus 40 divided by 20. You get minus 2. 80 divided by minus 40. Again minus 2. Common ratio. You are getting common ratio minus 2. Therefore, it is a geometric progression. Example number 4. The terms 4x16 are consecutive terms of a geometric progression. What is the value of x? We know if it's geometric progression, the common ratios are equal. So what's the common ratio if you take these two? X divided by 4. If you take these two, what's the common ratio? 16 over x. But if this is a geometric progression, these two are equal. Then you can solve for x. Cross multiply x into x, x squared. 4 times 16, 64. Then you can take it to other side. X squared minus 64 is equal to 0. This is solving quadratic equations. This is difference between two square terms. I can write down the factors as x minus 8 and x plus 8. When you get the product is 0, we can write down either this factor is 0 or the other factor is 0. So what are the solutions? X can be 8 or x can be minus 8. Exercise 16.1. Select and write down the geometric progressions from the number sequences given below. So you need to identify what are geometric progressions. When you take this sequence, what's the common ratio? 4 divided by 2. You get 2 here. 8 divided by 4, again 2. So common ratio two. That's it. So it's a geometric progression. This one, take any term, divide by its previous term. Minus minus division, you get plus 3. Minus 54 divided by minus 18, you get plus 3. So you get common ratio 3. That's a geometric progression. This one, start from any term. 32 divided by 64. You get half. 16 divided by 32. Again half. 8 divided by 16. You get same ratio. Therefore, it's a geometric progression. Look at this one. Any term divided by its previous term. If you take 30 divided by 10, you get 3 now. 120 divided by 30, you get 4. You are not getting same ratio. No common ratio. Not geometric progression. This one. Take any term, divide by its previous term. 6 divided by minus 2, you get minus 3. Minus 18 divided by 6, you get minus 3. 54 divided by minus 18, minus 3. So, same ratio. That's a geometric progression. Now, try this one. Take any term, divide by its previous term. 3 times 27 is 81. So, 1/3. 3 divided by 27. 1/9. Here, no need to do the next one. We can see not a common ratio, not geometric progression. This one, starting from any term, divide by its previous term. Here, how many places you need to move? 1, 2, 3, 4. 1, 2, 3, 4. That means we can convert to 20 divided by 2. 20 divided by 2 is 10. When you take the other term, 0.02 divided by 0.002. 1, 2, 3. 1, 2, 3, again 20 divided by 2, that's 10. Third one, 0.2 divided by 0.02. 1, 2. 1, 2 means again that's 20 divided by 2, you get 10. So, same ratio. Therefore, it's a geometric progression. Look at this part. Take any term. I'll write this way because these are fractions. 1/6 divided by half. 1/6 multiplied by the reciprocal. You get 1/3. Take any term, divide by its previous term. 1/18 multiplied by 6. Again, you get 1/3. Look at the next term. 1/36 divided by 1/18. 1/36 multiplied by 18. 36 and 18, that's multiplied by 2. Now you are getting half as a ratio. So, is this a geometric sequence? No, because you are not getting same ratio, not same ratio. Therefore, not geometric progression. Now we'll look at how we can find nth term of a geometric progression. Now we'll take first term as a, so first term, we'll denote it by T1. T1 is the first term. I'll take A. And this is a geometric progression. I can take R as the common ratio. If I take R as a common ratio, what's the second term? Second term I can write T2. Multiply the first term by the common ratio. A times R, AR. How can I get the third term? Multiply the second term by R again. That's T3 is AR times R. AR squared. How you get the fourth term? Fourth term I'll take as T4. AR squared times R again. AR cube. Now look at carefully and identify a pattern. What can you see? If this is first term, here this is A and no R term. Here this one, 2 becomes, this power is 1. If this is 3, the power is 2. I can rewrite as A R 2 minus 1. This one I can write A R squared. Squared, how can I write? This is as 3 minus 1. Fourth term, I can write 4 minus 1. And here, what is this one? Nothing means R to the power 0. R to the power 0 is 1 minus 1. Now, if I want any general term as nth term, how can I write the formula? Nth term I can write as Tn is the R to the power. What's the pattern? This number, that means n minus 1. So if you see the pattern, you can easily get this formula. So this formula represents to find out any nth term by using the first term and the common ratio. So Tn is the nth term. N is number of terms. A is the first term. And R is the common ratio. So if you know the common ratio, first term and number of terms, you can find out any term using this formula. So remember this, for a geometric progression you can use Tn. Nth term formula is A into R to the power n minus 1. So when you take fifth term, that's T5. So what is fifth term? Fifth term T5 becomes A R 5 minus 1 power 4. 20th term T20. How can I write? A R 20 minus 1 19. T56. A R 56 minus 1 55. So always you need to subtract 1 from n. Now we'll look at these progressions and you are asked to find out the separate terms. First one, you are asked to find the 10th term. So what is 10th term? That means T10. You can apply the formula. But before that, you need to identify what is R and A. A is the first term. So we'll write down what are the terms we know. We know A equals 7. What's the ratio? Ratio is any term divided by its previous term. You get 2 there. So you know A and R, and we need 10th term, T10. What is T10? According to the formula, AR to the power 10 minus 1, 9. Now A is 7, R is 2. So 2 to the power 9. 2 to the power 9 is 512. So you know 2 to the power 7 is 128. 128 multiplied by 2. 256 multiplied by 2 again is 512. So 7 times 512 is 7 times 2, 14, 1 remaining, 7 times 1, 7, plus 1, 8, 7 times 5, 35. 3,584. Look at the next one. You are asked to find out the 8th term. That is T8. What you know? You know the first term is 3. The ratio, common ratio is 6 divided by 3. You get 2. Now apply the formula. T8 is AR to the power 7. 8 minus 1. A is 3. R is 2. 2 to the power 7. What is 2 to the power 7? 128. 128 multiplied by 3. 3 times 8, 24. 2 remaining. 3 times 2, 6. 6 plus 2, 8. 3 times 1, 3. So 384 is the 8th term. This one, you are asked to find out the 20th term as a power of 2. So T20. What is T20? AR to the power 19. Now identify what is A. A is 1 over 8. Ratio. Ratio is any term divided by its previous. So we will take this one. 2 divided by 1, you get 2. Apply to the formula. 1 over 8 multiplied by 2 to the power 19. Now we need to simplify and write this as power of 2. 2 to the power 3 is 8. So 2 to the power 19 divided by 2 to the power 3. Same base, different powers division, we subtract the powers. 19 minus 3, you get 16. So the answer is 2 to the power 16. Next one. Find 20th term as a power of 3 now. Identify the first term. First term is root 3. What's the ratio? Common ratio is, you can do this way, 3 divided by, or this is the easiest way. 3 root 3 divided by 3. You get root 3. Now we know T20 is AR to the power 19. A is root 3. R is root 3 to the power 19 now. Same base, different powers. We add the powers. Multiplication, we add the powers. Root 3 is the number. Root 3 to the power 1 and 19, you get 20. So when you simplify, what is root 3? 3 to the power half. 3 to the power half multiplied by 20. What you get? Half times 20, you get 10. So the answer is 3 to the power 10. Example 1 in your textbook. Find the 5th term of the geometric progression with first term 3. A is 3. And the common ratio R is 2. You are asked to find out the 5th term. What's that? T5. What is T5? AR to the power 5 minus 1. That's 4. A is 3. R is 2. Now simplify. 2 to the power 4 is 16. 3 times 16. 48. So 5th term of this sequence is 48. Example number 2. Find the 5th and 7th terms of the geometric progression. So we need to find out T5 as well as T7. If this is T5, what's the formula? AR to the power 5 minus 1 becomes 4. If this is T7, AR to the power 7 minus 1 is 6. What is A? A is 81. What's R? We'll take these two. 9 divided by 27. 9 times 3, that's 1/3. Now apply to the formula. A is 81. 1/3 to the power 81 we know 3 to the power 4. 3 times 3 times 3 times 3. And here you get 3 to the power 4 in the denominator as well. Same base, different powers. You subtract the powers, you get 1. 4 minus 4, 0. 3 to the power 0 is 1, or you can cancel out these two. So fifth term is 1. What about seventh term? Starting from 81, 1/3 to the power 6. 3 to the power 4 is 81. 3 to the power 6 is there. Same base, different powers. Division, we subtract the powers. So you subtract these two, you get 1 over 3 to the power 2. What is 3 to the power 2? You get 1 over 9. So seventh term of this geometric progression is 1 over 9. Exercise 16.2. Question number 1. Find the sixth term of the geometric progression with first term is 5 and common ratio is 2. Sixth term, T6. Apply the formula. AR to the power 6 minus 1 is 5. 5 times 2 to the power 5. What is 2 to the power 5? 32. 5 times 32, 160. Question number 2. Find the sixth and eighth terms of the geometric progression with first term is 4 and common ratio is minus 2. T6 and T8. T6 is AR to the power 5. T8 is AR to the power 7. 8 minus 1. Now apply the values. 4 times minus 2 to the power 5. Make sure that you put brackets. Minus 2 to the power 5 means minus 2 5 times. 2 to the power 5 is 32. Is it positive or negative? We know when the power is odd, you get negative answer. If the power is even, you get positive answer. So minus 32 into 4. What's the answer? 4 times 2, 8. 4 times 3, 12. That's minus 128. This one, A is 4. R is minus 2 to the power 7. Again, odd power. 2 to the power 7 is 128, but this is minus multiplied by 4. So you get minus 512. Question number 3. Find the fourth and seventh terms of the geometric progression with first term minus 2 and the common ratio minus 3. T4 and T7. What is T4? AR to the power 3. What is T7? AR to the power 6. A is minus 2, put brackets, minus 3 to the power 3. 3 to the power 3 is 27, but this is negative 27 times negative 2. Negative, negative becomes positive. You get 54 as the answer. Seventh term, A is minus 2, R is minus 3. Now you get even power. Even power, you get a positive answer. So what is 3 to the power 5? 243. 243 multiplied by 3 again. 3 times 3, 9. 3 times 4, 12. 1 remaining. 3 times 2, 6 plus 1, 7. 729 here. That's positive. Multiplied by minus 2. You get a minus answer. 2 times 9, 18. 1 remaining. 2 times 2, 4 plus 1, 5. 2 times 7, 14. Minus 1458. Question number 4. Of a geometric progression, the first term is 1000. A is 1000. And the common ratio is 1/5. And find the sixth term. So that means T6. What is T6? AR to the power 5. Now substitute the values. 1000 times 1/5 to the power 5. We can split like this. 5 to the power 2, 5 to the power 2 and another 5. 2 plus 2 plus 1, you get 5. We know 5 to the power 2 is 25. So we can rewrite this as 25, another 25 and 5. 25 times this, you get 40. And when you divide by 5, you get 8. So what's the answer? 8/25 is T6. Question number 5. Find the sixth term of the geometric progression. From this, you can find out what is the first term. 0.0002. What's the ratio? Any term divide by the previous term. 1, 2, 3, 1, 2, 3. So that means 20 divided by 2, you get 10. Ratio is 10 and the first term is 0.002. Find the sixth term, T6. AR to the power 5. A is 0.0002. 10 to the power 5. That means you need to move 5 places to the right. 1, 2, 3, 4, 5. That means answer is 20. Question number 6. Find the fifth term of the geometric progression. A is given 3/8. What's the ratio? 3/4 divide by 3/8. Use this way. It's easy. 3/4 multiplied by 8/3. 3 get cancelled out. 4 times 2, 8. That's 2. So the common ratio is 2. Now find out T5. AR to the power 4. A is 3/8. R is 2. 2 to the power 4. What is 2 to the power 4? 16. 3/8 into 16. You get 8 times 2. 3 times 2. The answer is 6. Find the fourth term of the geometric progression given there. So what's the first term? 75. What's common ratio? Any term divide by the previous term. Or I can easily take the other one. 12 divided by -30. 6 times 2, 6 times 5. So the common ratio is -2/5. We know T4 is AR to the power 3. 4 minus 1. A is 75. R is -2/5 to the power 3. So 75 times. I can easily write down this one. -2 to the power 3 is a negative answer. -8. 2 times 2 times 2. And I can put -8. 5 to the power 3, I can write 5 to the power 2 and 5 to the power 1. So 5 to the power 2 is 25 times 5. 25 and 75, that's 3. 3 times 8, 24, and you get a negative answer. Divide by 5. So what's the answer? Negative 24 divided by 5. If you want the decimal answer, you can write minus 5 times 4, 20. For 40, that's 5 times 8. So the answer is fourth term is minus 4.8. Eighth question. Find the seventh term of the geometric progression. What's the first term? 192. What's the ratio? Take the easiest one, 48 divided by 96. So 2 times 48 is 96. So you get half as the common ratio. We need T7. A to the power, AR to the power 6. A is 192. R is half to the power 6. 192. 2 to the power 6. 2 to the power 5, 32. 2 to the power 6 is 64. So 3 times 64. You get 192. So what's the seventh term? Seventh term is 3. Ninth one. Find the ninth term of the geometric progression. 0.6, 0.3, 0.15. First term is 0.6. The common ratio is 0.3 divided by 0.6. That means 3 divided by 6. Half. We need T9. What is T9? AR to the power 8. A is 0.6. R is half to the power 8. So what is 2 to the power 8? 2 to the power 8 is 512. 2 to the power 7 is 2 to the power 6 is 64. 2 to the power 7 is 128. Multiplied by 2 again. 256. So 2 to the power 8 is 256. So we can write as a fraction by taking this one to this side. 6 divided by 2560. When you simplify, divide by 2, 3 over 1280. You get 3 over 1280. 10th one. Find the 10th term of the geometric progression. First term is 8. Ratio is 12 divided by 8. 4 times 2, 4 times 3. 3 over 2 is the common ratio. Find T10. That's AR to the power 9. A is 8. And R is 3 over 2. When you substitute, what you get? 8 into 3 to the power 9 over 2 to the power 9. Now I can rewrite 8 as 2 to the power 3. If I write this one as 2 to the power 3, I can simplify these two. When you subtract the powers for division, I can write this is 3 to the power 9 over 2 to the power 9 minus 3, 6. So what's the answer? 2 to the power 6 is 64. What is 3 to the power 9? 3 to the power 4 is 81 and 81 times. So 3 to the power 5 is 243. Again multiply by 3. 729. 729 multiplied by 3. 2187. This is 4, 5, 6, 7. 7 multiplied by again another 9. 3 times 3, 9. 9 times 7, 63. 9 times 8, 72. 78. 7 remaining. 9 times 1, 9 plus 7. 16, 1 remaining, 9 times 2, 18 plus 1, 19. 19,683. Divide by 64. If you want the decimal answer, you can do long division and find out the answer. 19,683 divide by 64. This is 2 or 3? 3. 3 times 4, 12. 1 remaining. 3 times 6, 18 plus 1, 19. You get 4 remaining for 48. That's nothing. Then for 483, you get 7. 7 times 4, 28. 2 remaining. 7 times 6, 42 plus 2, 44. When you subtract, you get 35. So again you can divide 350. How many 64s? 5. When you take 6, that's too much. 5 times 4, 22 remaining. 5 times 6, 30, 32. You get 30 again. So you can write down the decimal answer as 307.5. Now we'll look at more examples using the formula Tn equals ar to the power n minus 1. Look at this question. You have given first term as 5. Second and also sixth term is given. T6 given 160. Find the common ratio. Earlier we found the nth term. If you know A and R, you can find out the nth term. Now the other way around. You have given first term and nth term and you are asked to find out the common ratio. So we need to find out R. But still we can use the formula. What is T6? T6 is AR to the power 5. That's equal to 160. What's A? Now substitute 5R to the power 5 is 160. When you divide this by 5, you get R to the power 5 is 5 times 315 and you get 32. How can we write 32 as a power of 5? Any number to the power 5? 2 to the power 5. 32 when you divide by 2, you get 5 times. You have to divide 1, 2, 3, 4, 5. So 2 to the power 5 is R to the power 5. Same powers you get, so you can compare the bases. So R becomes 2 in this case. So the ratio, common ratio is 2. Now look at this one. First term is 2. The sixth term is 486. So we can start from here. Sixth term you can write T6 is AR to the power 5. That's equal to 486. A is 2. 2 times R to the power 5 is 486. Divide by 2. R to the power 5 is 243. When you take 243, divide and see. Divide by 3. 81. Divide by 3. 27. 9. 3. 1. 1, 2, 3, 4, 5. 3 to the power 5. R to the power 5 is 3 to the power 5. Same powers, you can equate the bases. So R equals 3. Look at this one. Find R and write down the first 5 terms of a geometric sequence. So first we need to find out R and write down the 5 terms of a geometric progression. T5 is given, fifth term is given. So T5, how can I write? AR to the power 4. That's equal to 80. Now substitute a as 5. 5 times r to the power 4 is 80. Divide by 5. R to the power 4 is 16. What's 16? 2 to the power 4. R to the power 4 is equal to 2 to the power 4. So what's the R value? R equals 2. Do you get full marks for this question? If you write R is 2, you get half of the marks. What's the reason? When you take 16 minus 2 times to the power 4, what is minus 2 to the power 4? You get plus 16. So when you take any even powers, you have to think both positive and negative. So remember, when you get power even, only even, you get both pluses and minus. So I can write R as plus 2 or R as minus 2 for this sequence. So if R equals plus 2, what's the sequence? Starting from 5, 5 times 2, 10. 10 times 2, 20. 20 times 2, 40. 40 times 2, 80. If R equals minus 2, you get first term 5. Multiply by minus 2, you get minus 10. Minus 10 minus multiply by minus 2, plus 20. Plus 20 multiply by minus 2, minus 40. But you get fifth term positive. So that sequence also possible. So what you have to remember, when you are comparing powers with even powers, remember to take plus and minus. This one, seventh term is 192. So what is T7? AR to the power 6. That's given 192. And A equals 3. Divide this by 3. R to the power 6 is 3 times 6, 18. 3 times 6, 18 for 12. 3 times 4. 64. Again, power is even. You can get positive and negative answers. So when you take 64, 2 times, 2 times, 2 times like that, 2 to the power 6. I can write this one as plus or minus 2 to the power 6 is 64. That means R can be positive or negative 2. If this is positive 2, what's the sequence? Starting from 3. 3 times 2, 6. 6 times 2, 12. 12 times 2, 24. 24 times 2, 48. If it's negative 2, what's the sequence? Starting from 3. 3 times minus 2, minus 6. Minus 6 times minus 2, plus 12. Plus 12 times minus 2, minus 24. Minus 24 times minus 2, you get positive power for fifth term. Now look at this one. Now you're asking, you have given a sequence, which term is 1458 in this geometric progression. Now any term is given and you are asked which term is there. So from this sequence I can write the first term and also the common ratio, because it says it's a geometric progression. 6 divided by 2, that's 3. And we don't know which term. Tn is given 1458. What is T to Tn? AR to the power n minus 1. Now substitute the values. 1458 equals 2 times r 3 to the power n minus 1. First we need to divide this by 2. When you divide this by 2, you get 729 is 3 to the power n minus 1. So what is 729? We'll divide and see how many 3's are there. Divide by 3 again, 81, divide by 3, 27, 9 and 3. 1, 2, 3, 4, 5, 6. 3 to the power 6 is equal to 3 to the power n minus 1. Same basis now. You can compare the powers. 6 is equal to n minus 1. N becomes, when you take minus 1 to the other side, 6 plus 1, that's 7. So, 7th term is 1458. Look at this one. Which term is 320? We know A is 5. What's the ratio? 10 divided by 5, you get 2. We need to find out Tn, ar to the power n minus 1, but it's 320. A is 5, r is 2. Now substitute. What's the first step? Divide this by 5. 2 to the power n minus 1 is 5 times 6, 30. And you get 64. So what is 64? 2 to the power 6. Here can we write minus 2? Now the power is even. Do you think that you can write minus 2? Here you can't write minus 2 because this base is plus 2. You can't write minus 2, then you can't compare. So we can write 2 to the power 6 is 2 to the power n minus 1. Same basis, n minus 1 is equal to 6. So what is n? 6 plus 1, you get 7. Now we'll look at example 1. Find the first term of the geometric progression with common ratio 3. Common ratio is given 3 and the fourth term T4 is given 54. You're asked to find out A now. Earlier, everything given, you asked to find out R. Now, A is unknown, the first term. We'll try to find out. We know the fourth term is 54, so we can use that formula. What is T4? AR to the power 3. But we know that's 54. A unknown, but R is 3 now. A into 3 to the power 3 is 54. What is 3 to the power 3? 27. 27A is equal to 54. So what's the A value? 54 divided by 27. When you multiply by 2, you get 54. So A is 2. That means first term is equal to 2. Example number 2. Find the common ratio of the geometric progression with first term 5 and the seventh term is 320. And you are asked to list the first 5 terms as well. So in this question, we need to find out R. Use this formula. What is T7? AR to the power 6. Now substitute. 320 is 5 times R to the power 6. Divide by 5. You get 64 is R to the power 6. Now power is even. You can write plus or minus 2 to the power 6 for 64. R to the power 6. So same powers, you can compare the bases. r equals plus or minus 2. So if r equals plus 2, what's the sequence? Starting from 5. 5 times 2, 10. 10 times 2, 20. 22 times 2, 40. 42 times 2, 80. When you take minus 2, what are the terms? Starting from 5. 5 times minus 2, you get minus 10. Minus 2, minus 10 times minus 2, plus 20. Plus 20 times minus 2, minus 40. Minus 40 times minus 2, plus 80. So you need to write both the sequences to get full marks. Example 3. Which term is 1 over 64 of the geometric progression with first term 64 and common ratio is 1 over 4. So use the formula. What is Tn? Ar to the power n minus 1. Now the term is given 1 over 64. What is A? 64. R is 1/4 to the power n minus 1. Now when you want this one, 1/4, how can I write? I can write as 2 to the power 2 here. So I'll take 64 as 2 to the power 6. And this one as 2 to the power 2. Again 64, I can write 2 to the power 6. Now I'm taking this one down. Divide by 2 to the power 6. It's multiplication, so add the powers. You get 1 over 2 to the power 12. 6 plus 6 is 1 over 2 to the power. When I take this power here, what's the answer? 2n minus 2. 2 times n, 2n minus 2. Now, you can compare the powers because the bases are equal. So, what is the answer? If you are comparing the powers, I can write 12 is equal to 2n minus 2. Take minus 2 to the other side. 12 plus 2 is 14 is 2n. So, what's the n value? Divide this by 2. You get 7. Example number 4. The first term of a geometric progression is 160. A is 160. And sixth term, T6 is 1215. Find the common ratio of the progression. You are asked to find out R. Again, apply it to the formula. T6. T6 is equal to AR to the power 5. 1215 is A is 160, R to the power 5. Now divide by 160. 1250 divide by 160. So divide by 5 first. 5 times 3, 15 and 2. 5 times 2, 10. For 21, that's 4. For 15, that's 3. Now, can we write as power 5? 243 is 3 to the power 5. 32 is 2 to the power 5. That's equal to R to the power 5. Now, you can write this as 3 over 2 whole thing to the power 5 is R to the power 5. Same powers, you can compare the bases. So, what is R? 3 over 2. Example number 5. Find the common ratio and the first term of the geometric progression with third term is 48 and sixth term is 3072. Now this question is different to other questions. You are asked to find out both ratio and the first term, and two terms are given. So third term, T3 is 48 is given. How you write T3? AR to the power 2. And what is T6? That's 3072 AR to the power 5. Before we substitute A, we can simplify the two equations. Now we want to solve the two equations and two unknowns are there. What's the best way to solve? When you divide the two equations, one variable get cancelled out. A get cancelled out. So you can easily find out the ratio. So I'll take 2 divided by 1. 3072 divided by 48. A and A get cancelled out. R to the power 5 divided by R to the power 2. So what is this one? What's the value? You get R to the power 5 minus 2, you get R to the power 3. And when you simplify this one, divide by 4, you get 12. Divide by 4 again, 7, 28, 2 remaining for 27. 4 times 6, 24 for 32, 4 times 8. Again, you can divide by 12, 12 times 6, 72, 48, 12 times 4, 64 is the answer. Which number is 64? 4 to the power 3. 4 times 4, 16, 16 times 4, 64. Now same powers, you can compare the bases. I can write R as 4. Now we found R, you can use any one of the equation, 1 or 2, and find out the A value. So it's easy to plug it to the first equation. 48 is equal to A times R. We found 4. That's 4 squared. So what is A? 48 divided by 4 squared. 4 squared is 16. What's the answer? 3 times 16 is 48. The first term is 3. So first term is 3 and the ratio is 4. Example number 6 says the sixth term of a geometric progression is minus 8. Sixth term, minus 8. And the 10th term, T10 is equal to minus 128. Show that there are two such geometric progressions. Write down the first 5 terms of each progression. So, like before, we can write down two equations and solve for A and R, first term and the common ratio. T6 is AR to the power 5. T10 is AR to the power 9. If we take this one as 1 and this one as 2, when you divide 2 with 1, what you get? Minus 128 divided by minus 8. A get cancelled out. R to the power n over R to the power 5. Same base with different powers, you can subtract. 9 minus 4, R to the power 4. What's this one? When you divide by 8, 8 times 1, 8 for 48, 8 times 6. So you get minus minus becomes plus 60. Now the power is even. When the power is even, you can write down either positive or negative value. What's the value? 2 to the power 4 is 16. So minus or plus 2 to the power 4 is R to the power 4. Same powers, you can compare the bases. So r equals plus or minus 2. So that's why we get 2 such geometric progressions. Write down the first 5 terms. But before that, we need to find out the first term. I'll take the first equation. Minus 8 equals a times. I'll first take plus 2, 2 to the power 5. Minus 8 divide by 2 to the power 5. That's 32 is equal to a. 8 times 1, 8 times 4. A is negative 1 over 4. Then what's the next one? If it's negative 2 to the power 5, you get a negative answer here. Negative 32. So what's the a value? You get positive 1 over 4. If it's negative values, r is 2 and a equals this. What are the 5 terms? Starting from minus 1 over 4. Multiplied by 2. So when you multiply, 2 and 4 get cancelled out. You get minus half. Multiply by 2 again, you get minus 1. Minus 1 multiplied by 2, minus 2. Minus 2 multiplied by 2, minus 4. When you take negative minus 2, starting with 1/4, you are getting multiplied by negative 2 now. Negative half. Multiplied by negative 2. You get positive 1. Positive 1 multiplied by negative 2. You get negative 2. Negative 2 multiplied by negative 2. You get positive 4. So these are the terms for this sequence. Exercise 16.3 in your textbook. Find the first term of the geometric progression with common ratio r is 3 and the fourth term is given 108. Now use the formula, nth term formula. T4 is ar to the power 3. That's given 108. A we don't know, r is 3. 3 to the power 3 is 27. So what's the first term? 108 divided by 27. You get 4 times 27 is 108. So the value for a is 4. So we found out the first term as 4. Question number 2. Find the first term of the geometric progression with sixth term is 1701 and the common ratio is 3. Again, plug it to the formula. T6 is what? ar to the power 5. T6 we can substitute 1701 is a times 3 to the power 5. So what is 3 to the power 5? 243. So what's a? 1701 divided by 243. So when you simplify this, we get 7 times 243 is 1701. 7 times this, so a equals 7. So the answer is, first term is 7 for this equation. Question number 3. Find the first term of a geometric progression with common ratio half and eighth term as 96. use the formula. What is T8? AR to the power 7. That's given 96. R is half. When you simplify, you get A 2 to the power 7. 2 to the power 6 is 64. 7 is 128. So what's the A value? A equals 96 times 128. Now multiply. 128 multiplied by 96. 90 and 6. 9 times 8, 72. 9 times 2, 18. 18 plus this you get 25. 2 remaining. 9 times 1, 9 plus 2, 11. 6 times 8, 48. 6 times 2, 12 plus 4, 16. 1 remaining. 6 times 1, 6 plus 1, 7. When you add these two together, you get 12,288. 12,288 is the first term. Question number 4. The first term of a geometric progression is 5. A is 5. The fourth term, T4, is 135. Find the common ratio of the progression. You are asked to find out R. Use the formula. What is T4? AR to the power 3. T4 is given as 135. A is 5. And R we need to find. Now divide this by 5. What you get? 135 divided by 5. 5 times 2, 10. For 35, that's 7. R to the power 3. What's 27? 3 times 3, 9. 9 times 3, 27. 3 to the power 3 is R to the power 3. Same base, you can compare the bases. R equals 3. Next one. The common ratio of a geometric progression is 2. And the first term is 7. Which term is equal to 448? So Tn is given 448. So you are asked to find out. Now use the formula. What is Tn? AR to the power n minus 1. A is given 7, R is given 2. So first thing, divide this by 7. 2 to the power n minus 1 is 7 times 6, 42. For 28, that's 4. 64. 64 is 2 to the power 6. Even power. Even power you can write as positive or negative, but this base is plus 2, so you don't need to write down negative power. 2 to the power 6 is 2 to the power n minus 1. Same base, you can compare the powers. N minus 1 is 6, n equals 7. Question number 6. The common ratio of a geometric progression is 2. The first term is 1 over 32. Which term is equal to 256? That means you want to find out the n value. Use the formula. What is Tn? AR to the power n minus 1 is 256. A is 1 over 32. R is 2. So we'll simplify with power of 2. 2 to the power n minus 1. Here 32 is 2 to the power 5. What is 256? 2 to the power 8. 128 multiplied by 2, you get 256. So 2 to the power 8. Now when you multiply this, that means cross multiply, you get 2 to the power n minus 1 is 2 to the power 5 times 2 to the power 8. Same base, different powers multiplication, you add the powers. 2 to the power 13. 2 to the power n minus 1 is 2 to the power 13. Same bases, you can compare the powers. N minus 1 equals 13. N equals 14. Question number 7. Which term is equal to 3 5 over 9 of the geometric progression with first term 27 and the common ratio 2/3? And you are asked what is the n value. Again, take the nth term formula. What is Tn? Ar to the power n minus 1. But we'll write this one as improper fraction. 9 times 3, 27. 27 times 5, 32. So 32 over 9. Now substitute the values. That's equal to A is 27. R is 2/3 to the power n minus 1. Now we'll take 27 to this side. 32 divide by 9 and 27 comes here. That's 2/3 to the power n minus 1. Try to simplify what you get. This one I can write 2 to the power 5 is 32. This is 3 to the power 2 and 3 to the power 3. You get 3 to the power 5. I can rewrite this as 2 over 3 whole thing power 5. Same base, you can compare the powers. 5 equals n minus 1, n equals 6. Question number 8. Write down the first 5 terms of the geometric progression with first term 8 and the sixth term minus 256. So you need R to find out the sequence. Try to plug it to the formula. T6 is AR to the power 5. Substitute the values. A is 8, R to the power 5. Divide by 8. 8 times 3, 24. 8 times 2. Minus 32 is R to the power 5. What is minus 32? This is odd power. Definitely this should be minus 2 to the power 5. If you put 2 to the power 5, that's plus 32. Now, same powers, you can compare the bases. R is equal to minus 2. If you know R equals minus 2 and A equals 8, you can write down the first 5 terms. First term is 8. 8 times minus 2, minus 16. Minus 16 times minus 2, plus 32. 32 minus minus 2, minus 64. Minus 64 times 2, you get 128 plus. So this is the first 5 terms of the sequence. Question number 9. Show that there are 2 geometric progressions with first term 64 and ninth term 1/4. Write the first 3 terms of each such progression. We need to find out R. If there are 2 geometric progressions, that means you get 2 R values. We'll see. T9 means AR to the power 8. Substitute the values. And I can take 64 down. And also I can write 4 as 2 to the power 2 and 64 as 2 to the power 6. Then 2 to the power 8. I can write 1 over 2 to the power 8 is r to the power 8. This is even power. You can get either positive or negative values. So powers are equal. You can write r is plus or minus half. Then we see there are two geometric progressions and we'll write down the first three terms starting from 64. If r is plus half, 64 multiplied by half means divide by 2. 64 divided by 2, 32, divided by 2, 16, 16 divided by 2, 8. But you need only first three terms. If r is negative half, what's the answer? First term is 64. Then the second term becomes minus 32 and the third term is plus 16. Question number 10. The fourth term of a geometric progression is 48. Seventh term is 384. Then find the common ratio and the first term. A and R. We can use the formula. What is T4? AR to the power 3. That's our first equation. What is seventh term? AR to the power 6. When you divide the two equations, A get cancelled out. So 2 divided by 1, 384 divided by 48. A get cancelled out, R to the power 6 over R to the power 3. Same base, different powers, you can subtract the powers. R to the power 3. When you simplify this, we see 48 times 8 is 384. So you get 8 is r to the power 3. This is odd power. You can straight away write 2 to the power 3 is r to the power 3. Then what's the r value? R value is 2 because you get the same power. Now we found out r. What's the first term? You can take the first equation and substitute. 48 equals A, R is 2 to the power 3. 2 to the power 3 is 8. So 48 divided by 8 is the first term. You get 6 as the first term. So first term is 6 and R is 2. 11th one, show that there are two geometric progressions with third term is minus 45 and the fifth term 1125 minus. So you are asked to solve these two equations and solve for A and R. If there are two equations, that means you need to get two R values. What is T3? AR to the power 2. That's our first equation. T5 means AR to the power 4. When you divide the two equations, 2 by 1, I am getting minus 1125 divided by minus 45 is equal to R to the power 4 over R to the power 2. So when you simplify this, you get R to the power 2. Now this one, 5 times 9, 5 times 2, 10, 5 times 2, 10, so 225. What is 225? That's a square term. 15 squared. What is 9? 3 squared. And minus minus becomes plus. I can write this as 15 divided by 3 whole thing squared. So that means 5 squared. Now this is even power. In even powers, you have to think about taking positive and negative numbers. So plus or minus 5 squared is r squared. You can write r as positive or negative 5. So what's the a value now? If r equals positive 5, use the first equation. Minus 45 equals a into 5 squared. So minus 45 over 25 is the first term. 5 times 5, 5 times 9. Minus 9 over 5 is the first term. Then what's the other sequence? If r equals negative 5, you can substitute and get the other value. So you get the same first term because minus 5 squared is also plus 25. So you get negative 9 over 5. Here you don't need to find out a because only they are asking show that there are two geometric progressions. So we got two r values. That means you get two sequences. Question number 12. The fourth term of a geometric progression is 100. Ninth term is 3 and 1/8. Write the first 5 terms of the progression. Use simultaneous equations. First term you can write T4 as AR to the power 3. Second one AR to the power 8. When you divide the two equations, what you get? I'll rewrite this as improper fraction. 8 times 3, 24 plus 1, 25. 25 over 8 divided by 100 is equal to a get cancelled out, r to the power 8 over r to the power 3. So you get r to the power 5, 8 minus 3. Here, how you simplify? 25 over 8 multiplied by its reciprocal. 20 times 4, 1 over 32 is r to the power 5. We know 32 is 2 to the power 5. So, I can write half to the power 5 equals r to the power 5. R equals half. We found r equals half. So, what's the first term? I'll take the first equation, substitute the r value. 100 equals 8 times half to the power 3. 2 to the power 3 is 8. So, a equals 8 times 100, that's 800. Now, we need to write down first 5 terms starting from 800. Divide by 2. Multiply by half means same as divide by 2. 400. 400 divided by 2. 200 divided by 2. 100 divided by 2. You get 50. So these are the 5 terms in the progression. Question number 13. Show that there are two geometric progressions with fifth term 40 and ninth term 640, and write the first 5 terms. T5 you can write AR to the power 4. This one AR to the power 8. You can divide and get rid of A. When you divide 2 and 1, 640 divided by 40, you get r to the power 8 over r to the power 4. Same base, different powers, you can subtract. 8 minus 4, you get 4. Here, what you get? 4 times 1, 4 times 8. 4 times, what's the answer here? 4 times 1, 4. For 24, that's 6. Now the even power, when you take this number, you can get plus or minus. So, which number is 16? 2 to the power 4. I can write plus or minus 2 to the power 4 is 16. So, same power, you can compare the values. R equals plus or minus 2. Now, you need to find out the A values. If R equals plus 2, what's the A value? I'll plug it to first equation. 40 equals A into 2 to the power 4. 2 to the power 4 is 16. So, A is 40 divided by 16. 4 times 4, 4 times 10 divided by 2, 5 and 2. So, the A value is 5 over 2. Now, we'll write down the sequence. First 5 terms starting from 5 over 2. Multiply by 2. 2 get cancelled out and you get 5. Multiply by 2. 10 multiplied by 2. 20 multiplied by 2. So 1, 2, 3, 4, 5. That's the sequence. If R is negative 2, what's the A value? Even this is negative or positive, you get plus 16, 2 to the power 4. So you get A, same value, 5 over 2. Now we'll find out the 5 terms. Starting from 5 over 2, multiplied by negative 2, you get negative 5. Negative 5 multiplied by negative 2, plus 10. Plus 10 multiplied by negative 2 minus negative 20. Negative 20 times negative 2 plus 40. So that's the other sequence. Now we'll look at some of the first n terms of a geometric progression. Earlier we discussed about nth term formula. Now we need to find out sum of first n terms. So what's the symbol we use for sum? Can you remember in previous grade? For arithmetic sequence we use S symbol. S for sum. So sum of 7 terms. Is it S7? You have to remember what is S7 means. Sum of first 7 terms. Not just sum of 7 terms. First 7 terms. What is S5 means? Sum of first 5 terms. So what is Sn means? Sum of first n terms. So you need to remember what is Sn means. You can't just take any n terms and add. You have to take first n terms. Now we'll take an example. I have given S5 means the sum of 5 terms, first 5 terms of this sequence. I just want to do a small thing to get a formula later. Just take this one and I want to find out the ratio. What's the ratio here? First term is 6. This is multiplied by 2. So ratio we can find 12 divided by 2 is 12 divided by 6. You get 2. Ratio is 2. And first term is 6. I want to multiply this first equation by 2. What you get? 2 times S5. When you multiply all terms by 2, 2 times 6, 12. I'm writing this here. I'll leave a space and write down here. 2 times 12, I get 24. 2 times 24, I get 48. 2 times 48, I get 96. 2 times 96, I get 192. So this is my second equation. Now, which one is bigger? 2s5 is bigger. So I am taking 2 minus 1. When I take 2 minus 1, 2s5 minus s5, I get s5. 2 minus 1. Here, what happens when you subtract? This whole set get cancelled out. Everything get cancelled out. What's remaining? We get 192 minus 6. So what is S5? I can write 192 minus 6 means 186. So 2 minus 1 is 1. So S5 is 186. Now we'll take the same sequence other way around. Last term first, like that, first term last. Now what's the ratio now? The ratio is different. Ratio is 48 divided by 96 now. You get half now. That's less than 1. Here R is 2. So R is greater than 1 in this case. Now R is less than 1 because you got a fraction. Now same thing I need to do. I can multiply the first equation by half. Half times S5, half S5. Half times 96, you get 48. 48 divided by 2, 24. 24 divided by 2, 12. 12 divided by 2, you get 6. 6 divided by 2, you get 3. I'll take this one as 2. Now, which way I need to subtract? 1 minus 2 or 2 minus 1? Half is smaller than 1. So, I can do 1 minus 2 now. So, 1 minus half, you get half. S5 is equal to. When I subtract these two, this whole set get cancelled out. This set get cancelled out. So, what's remaining? 96 minus 3. So 96 minus 3 is 93. Half S5 is 93. So what is S5? 2 times 93. 186. I'm getting the same answer. But remember this one. When the ratio is greater than 1, I need to subtract. The bigger one is this minus this, 2 minus 1. Here I need to subtract 1 minus 2. So you need to remember this to find out the formula for sum of n terms. Now we'll look at how to get the sum of n terms. Okay, so what is Sn? Sn is the sum of first n terms. A is the first term. A times R, AR. Next one, AR squared. AR cube. So likewise, what's the nth term? AR to the power n minus 1. This is my first equation. Now think that R is greater than 1. Now I need to, what's the ratio here? AR divided by A. R is the ratio. So I want to multiply this by R. So first equation by R. So what am I getting? RSN equals A into R. I get AR. AR into R, AR square. So likewise, I am getting all these terms. This previous term, when I multiply by R, I get AR to the power n minus 1 and AR to the power n minus 1 multiplied by n. I get AR to the power N. Now, when I subtract these two, which way I need to do? R is greater. 2 minus 1. R Sn minus Sn equals, this whole set get cancelled out. You get ARn minus A. So take A out, you get R to the power n minus 1. And when you take Sn out, you get R minus 1. So what is Sn? We get a formula, something like this. Now I want to do the same thing for R less than 1. If R is less than 1, which way I need to subtract? 1 minus 2, because this is smaller. When I do 1 minus 2, I get Sn 1 minus R equals A minus AR to the power n. When you take A out, I get A 1 minus R to the power n is Sn, and also we need to divide this by 1 minus R. Now look at carefully. What's the difference between these two formulae? Same terms, A, only difference is this is R to the power n minus 1 and R minus 1, here other way around. So it's easy to remember. When you forget about n, this is R minus 1. You divide by same thing. But here only n is extra. Here if this is R less than 1, you have to take 1 minus R. So this is for R greater than 1 and this is for less than 1. So if you're asked to find out sum of n terms, you need to use this formula for a geometric progression. Now look at this example. Find the sum of first 9 terms of this geometric progression. So that means S9. What is A? First term is 7. What is the ratio? 14 divided by 7. That's 2. So what's our greater than 1? 2 means greater than 1. So we found out R is greater than 1. So what's the formula? Sn formula, we have to select A times R to the power n minus 1 over R minus 1. Now plug it to the formula for S9. That means n equals 9. A value is 7. R is 2. 2 to the power 9 minus 1 over 2 minus 1. Now, what's 2 to the power 9? We did that before. 512. So, I can write 512 minus 1 is 511. So, what's the answer? 7 times 511. I get 3577. Now look at this one. Find S9. Again, the first term is 5 and what's the ratio? Minus 10 divided by 5. You get minus 2. Minus 2 means R less than 1. So what's the suitable formula? You need to take Sn equals A times 1 minus R to the power n over 1 minus R. Now we need S9. N equals 9. A is 5. R is minus 2 to the power 9 over 1 minus minus 2. Again, minus 2 to the power 9. you get a negative answer, minus 512. Minus and minus becomes plus. So 5 times 512 plus 1, 513. 1 minus minus 2 becomes 1 plus 2, that's 3. Now when you simplify, you get, multiply by 5, 5 times 3, 15, 1 remaining, 5 times 1, 5 plus 1, 6, 5 times 5, 25, divide by 3. 3 times 8, 24, 3 times 5, 15, again 5. So S9 is 855. So when you want to find out the sum, first identify whether R is greater than 1 or less than 1, and then select the suitable formula. Now look at this one. You are asked to find out how many terms are there to get 855 as a sum. So sum is given now. So Sn is given 855 for this sequence. So that means we know A value is 5, R equals minus 10 divided by 5, that's minus 2. Now this is the reverse of the previous question. Previous question, you have given the sequence and asked you to find out S9, and here a value is given. So the same answer is given that we got here. So then what should be the answer? Before we do that, we need to get N as 9. So we'll try that out. So Sn is 855 and you need to find out N. Now what we do? R is less than 1. So you use the correct formula. So Sn equals A 1 minus R to the power N over 1 minus R. That's 855. Now substitute the values. 5. 1 minus R is minus 2 to the power N over 1 minus 2 is equal to 855. This one you can write 1 minus 2 to the power N is equal to 1 minus 2 is plus 2, that's 3. 3 times 855, divide this by 5. We'll divide this by 5 first. 5 times 1, 5, 35, 7, again 1. So 3 times 171, 513. Now we'll take 1 to the other side. You get minus 2 to the power N is equal to, when you take 1 to the other side, 513 minus 1, 512. Now consider the negative power for the next side. So that means multiply by negative. You get negative 2 to the power N is negative 512. So what is 512? We know 2 to the power 9 is 512. But here it's negative. So negative 2 to the power 9 is negative 512. So same base, different powers, you can equate the powers. So n is equal to 9. So that's how you do the reverse process. Look at this question. You have given a sequence and this is geometric progression. Otherwise you can't use the formula. Find S9. First identify A and R. R, we can use that one, 32 over 64, half. Half means less than 1. Use the proper formula. Sn equals A 1 minus Rn over 1 minus R. Substitute the values. A is 256. 1 minus half to the power 9 because n is now 9 over 1 minus half. Here I can simplify this. 256, 1 minus half to the power 9 over half. So what's the value? I can write divide by half means multiply by 2. 256 multiplied by 2, 512. This one, I get 1 minus 2 to the power 9, 512. Now 1 I can write 512 over 512 because I need to subtract these two fractions. So 512 minus 1, you get 511, and this 512 get cancelled out. You get the answer as 511. So S9 value is 511. Look at this one. You have given a sequence. How many terms are there to get sum of first n terms is 511. So this is the reverse of the previous one. So previous one, you have given same sequence and now the sum is given. You are asked to find out n. So what's A? 256. What's R? 64 divided by 128, that's half. Now we need to plug it to Sn formula. Which one is suitable? This is less than 1. R is less than 1 means you can use 1 minus Rn over 1 minus R. What's the first term? 256. 1 minus half. 1 minus half to the power n. That's equal to 511. So 1 minus half is half. When you multiply that with 512, you get 511 divided by 2. 256. 1 minus half to the power n. Or I can write n here. Now take this one down. I get 511 divide by 2 and divide by 256 is equal to 1 minus 1 over 2 to the power n. When you take 1 to the other side, you get this one 511 over 512. Minus 1 is equal to minus 2 over n. When you switch the places, you can get rid of this minus sign. I can write 1 minus 511 over 512 is 1 over 2 to the power n. This one 512 over 512 as 1. So that's 1 over 512 is equal to 1 over 2 to the power n. You can compare this. 512 is 2 to the power 9. So when you take the denominators, I can take same bases. So the powers are equals. So you get n equals 9. Example number 1. Find the sum of the first 5 terms of the geometric progression, both by finding the first 5 terms and adding them up, and by using the formula for Sn. So first 5 terms. Now look at the geometric progression. 2, 6, 18 given. We need another 2 terms. What's the ratio? Ratio is 6 divided by 2, you get plus 3. The first term is 2. So that means what's the next term? 18 multiplied by 3. 54. So 54 times 3, 162. So when you add all together, so what's the sum of first 5 terms? 6 plus 2, 8. 8 plus 18, 26. 26 plus 54, 80. 80 plus 162, you get 242. So the sum of 5 terms is 242. Now we'll use the formula. R is greater than 1. That means you can use Sn as Rn minus 1 formula. Now we need S5. A equals 2, R equals 3. 3 to the power 5 minus 1 over 3 minus 1. 3 minus 1 is 2. This 2 and this 2 get cancelled out. You are getting 3 to the power 5 minus 1. So what is 3 to the power 5? 243 minus 1. You get 242. So you can either use the formula or just adding these, you get the same answer. Example number 2. Find the sum of the first 6 terms of the geometric progression, 120 minus 60, like that, using the formula. First 6 terms, that means you need S6. What's the first term? 120. What's R? Minus 60 over 120. You get minus half. This is less than 1. So what's the formula we have to use? 1 minus r to the power n over 1 minus r. Sn. S6 we need. A is 120. R is minus half to the power 6 over 1 minus half. Now try to simplify. 120, 1 to the power, you get half to the power 6, and this is even power. You get positive answer. 2 to the power 6 is 64. So you get here positive answer. So 1 minus positive answer 1 over 64. This one 1 plus half. 1 plus half you get, what's 1 plus half? 3 over 2, or I can rewrite this as 120. 1 I can write 64 over 64. 1 I can write 2 over 2. Then when you simplify, 120, 64 minus 1, 63. This one, 2 plus 1, 3. So, straight up we'll multiply. 120, 63 and 64. Divide by 3 over 2 means take the reciprocal. 2 goes here, 3 goes down. So, when you simplify, what you get? 3 times 2 and 1. And 2 and this one you get 32. 4 times 8, 4 times 30. Then again divide by 2, you get 4 and 15. So you can't simplify further. So what's the answer? You get 15 into 21 divide by 4. So when you multiply, what you get? 21 divided by 15. When you add it, you get 315 divided by 4. Four times 8, 32. 3 remaining. For 30, that's 7. And for 20, that's 5. 78.75. 78.75. Example number 3. Find how many terms of the initial terms need to be added from the geometric progression 5, 15, 45 in order for the sum to be equal to 1820. 1820. We need to find out n. What you know? You know A equals 5. And what's the ratio? 15 divided by 5 plus 3. So we can apply the formula. So this is greater than 1. So you can use Sn as A r to the power n minus 1 over r minus 1. Now this value is given 1820. A is 5. R is 3. Three minus 1 is 2. Multiply by 2, you get 3640. Divide by 5 is 3 to the power n minus 1. Divide by 5. 5 times 7, 5 times 2, 10 and 8 is equal to 3 to the power n minus 1. When you take minus 1 to the other side, 729 equals 3 to the power n. Now, what is 729? 3 to the power 5 is 243. 243 multiplied by 3, you get 729. So that means 3 to the power 6 is 3 to the power n. Same base, you can compare the powers. N equals 6. Exercise 16.4. Find the sum of the first 5 terms of the geometric progression with first term 4 and the common ratio 3, both by writing the first 5 terms and adding them up and also using the formula. So you need first 5 terms. R equals 3 and A equals 4. So we'll write down the first 5 terms starting from 4. 4 times 3, 12. 12 times 3, 36. 36 times 3, 108. 108 times 3, 324. When you add all together 5 terms, what you get? 12 plus 4, 16. 16 plus 36, 52. 52 plus 108, 160. 160 plus 324, you get 484. Now we'll use the formula. So R is greater than 1. So which one we need to use? Sn equals A r n minus 1 over r minus 1 formula. We need S5. What's the first term? 4. Ratio is 3. 3 minus 1. 4, 3 minus 1 is 2. 3 to the power 4 is 243 minus 1, 242. Now simplify. This is 2. 2 times 242. 2 times 2, 4. 2 times, so 484. Using the formula as well as by adding the 5 terms. Question number 2. Find the sum of the first 5 terms of the geometric progression of this. First term is 2. What's the ratio? 8 divided by 2, you get 4. So the ratio is 4 means greater than 1. So you can use the formula. Which formula? Sn equals r to the power a times r to the power n minus 1 over r minus 1. First term is 2, ratio is 4. And we need first 5 terms. N is 5. 4 minus 1. So 2, 4 minus 1 is 3. What is 4 to the power 5? 4 to the power 3, 64. 64 times 16. 6 times 4, 24. 6 times 6, 36 plus 2, 38. 1024. 1024 minus 1 is 1023. Now multiply by 2. 2 times 3 is 6. 402. Divide by 3. So what's the answer? Answer is 3 times 6, 18. 3 times 8, 24. 3 times 2. So the answer is 682. Question number 3. Find the sum of the first 6 terms of the geometric progression with first term is 72 and the common ratio is 1/3 and you are asked to find out S6. R is less than 1. So use the correct formula. 1 minus Rn over 1 minus R. A is 72 and 1/3 to the power 6 because you need sum of first 6 terms. 1 minus 1/3. I can write 3 to the power 6 is 3 to the power 5 is 243 multiplied by 3 again. 729. So I can write this one as 729 over 729 over this. 1 I can write 3 over 3. Now simplify this. 72. 729 minus 1, 728. You get 729 here. 3 minus 1, 2. 2/3. Divide by 2/3 means multiply by 3 over 2. Now try to simplify. 2 times 36. Then 3 times 12. 3 times 1, 2, 6, 4 and 3. Then again you can divide by 3. 3 times 4, 3 times 81. And 3 times 81 you get 27. Then 4 times 728. 32. 2912. Divide by 27. So you get 2912 divide by 27. You can do long division. 2912 divided by 27. You get 2. So 25, nothing for 212. So how many 27s for 212? That's 7. 7 times 7, 49. 7 times 2, 14 plus 4, 18. When you subtract 3, so 23. So you can write as 107, 23 over 27. Question number 4. Find the sum of the first 7 terms of the geometric progression. This. So 7 is 7. What's A? What's R? Minus 6 over 3. You get minus 2. Minus 2 is less than 1. That means which formula is suitable? 1 minus Rn over 1 minus R. Now plug the values. N is 7. A is 3. R is minus 2. When you simplify, what you get? 1. 2 to the power 7 is 128. That's negative. So 128 plus 1, 129. And 1 minus minus 2 becomes 3. So 3 get cancelled out. The answer is 129. Question number 5. Find the sum of the first 6 terms. So S6. First term is 18. What's R? 8 divided by 12. 4 times 2, 4 times 3, 2/3. This is less than 1. So less than 1 means what's the suitable one? 1 minus Rn. Plug the values. A is 18. 1 minus 2/3 to the power 6 because n is 6. 1 minus 2/3. Now 18 is there. 1 I can write. What is 3 to the power 6? 3 to the power 5 is 243. Multiply by 3, 729. I'm writing 729 over 729 as 1. 2 to the power 6 is? 2 to the power 5 is 32, 64. And this one I can write 3 over 3. So when you simplify, you get 18, 729 minus 64, 665. Over 729. This one 3 minus 2 is 1. So divide by 1/3 means multiplied by 3. Now simplify. 729 I can divide by 9. 9 times 2, 9 times 81. 3 and 81 I can divide this by 81, that's 27. So 2 times 665. What's the answer? 1330 divide by 27. So what's the answer? 1330 divided by 27. 27 times 4. 4 times 7, 28. 4 times 2, 8 plus 2, 10. 25 remaining. For 250, we get, when you multiply by 7, 189. 9, that's less than 250. So it's 9. So 9 times 7, 63. 9 times 2, 18 plus 6, 24. So what's remaining? 7. So the answer is 49 and 7 over 27. Question number 6. Show that the sum of the first 6 terms of the geometric progression is 26 and 26 over 27. So we have to find out S6. What's the first term? 18. What's ratio? 2 over 6 is 1/3. Now use the formula. This is less than 1. Use the correct formula. Sn equals 1 minus Rn over 1 minus R. S6 we need. N is 6. First term is 18 and R is 1/3. 1 minus 1/3. Now, what's 3 to the power 6? 729. So I can write this one as 729 over 729 over 1 minus 729. Here I can write 3 over 3. So when I simplify this, I get 18. 729 minus 1, 728. Divide by 729. And here 3 minus 1 is 2. Divide by 2/3 means multiplied by 3 over 2. Now divide by 9. 9 times 2, 9 times 81. Divide by 3, you get 27. This 2 and this 2 get cancelled out and you get 728 divided by 27. Now we'll divide and see whether you get this answer. So 728 divided by 27. So multiply by 2. You get 54. 18 remaining. So 188. So we'll see with 6. 6 times 7, 42. 6 times 2, 12 plus 4. 12 plus 4, 16. When you subtract, what you get? 26 remaining. So the answer is 26 and 26 over 27. Seventh one. How many of the initial terms should be added from the geometric progression for the sum to be equal to 2046? Sn is given 46. We need to find out n. A is the first term. Ratio we can find using term divided by the previous. Then this is greater than 1. Use the correct formula. Sn 2046. A is 2, R is 2. 2 minus 1 is 1. Then when you divide by 2, what you get? 1023 is 2 to the power n minus 1 when you take it to the other side. 1024 is 2 to the power n. So what is n? What is 1024? 2 to the power 8 is 256. 2 to the power 9 is 512. 512 divided by 2, multiplied by 2, you get 1024. That means 2 to the power 10 is 2 to the power n. Same ways you can compare the powers. N is equal to 10. Question number 8. How many of the initial terms should be added from the geometric progression with first term 4 and the common ratio is 2 for the sum to be equal to 1020? So this is ratio 2 greater than 1. So identify the appropriate formula. Then you can plug it to the formula. Sn equals 1020, A equals 4, R equals 2. 2 minus 1 is 1. When you divide this by 4, 255 is 2 to the power n minus 1. When you take 1 to this side, 256 is 2 to the power n. So we know 2 to the power 7 is 128. 128 multiplied by 2. That means 2 to the power 8 is 2 to the power n. So n equals 8. Ninth one, find the number of initial terms that need to be added from the geometric progression for the sum to be equal to 9831. Identify A and R. R is minus 12 divided by 3. You get minus 4. R is less than 1. So what's the formula? A 1 minus r to the power n over 1 minus r. Now plug it to the formula. 9831 is equal to 3 times this n 1 minus 4. You get 5 here. So 9831 multiplied by 5 divide by 3, you get 1 minus 4 to the power n. Now divide by 3. 3 times 3, 3 times 2, 6. For 23, 3 times 7, 21, again 7. Now multiply by 5. 5 times 7, 35. 35 plus 3, 38. 13, 1 remaining. 5 times 3, 15 plus 1, 16. That's equal to 1 minus 4 to the power n. When you take it to the other side, you get minus 4 to the power n is equal to 16384. Then take minus to the other side. Minus 4 to the power n is equal to minus 16384. So we'll see how many 4s are there. Divide by 4. 8, 9, 36. 4 times 6. Again divide by 4. 1024. Divide by 4. Divide by 4. You get 64. 4 times again 16. 4 times 4. 1, 2, 3, 4, 5, 6, 7. So this is a minus answer. You get minus 4 to the power n is minus 4 to the power 7. So what's n? N equals 7. Now we'll solve some more problems related to geometric progression. Look at example number 1. Of a geometric progression, the sum of the first and second term is equal to 9. Sum of the first and second term. And the sum of the fourth and fifth terms is equal to minus 72. Find the first 5 terms of the progression. So we'll write down the given information. First and second term means S2. That's 9. The sum of fourth and fifth, you can't write S4 and S5. Separately, you have to write down fourth term and fifth term and get the sum. So what's fourth term? T4 AR to the power 3. Fifth term AR to the power 4. So sum of these two terms is equal to minus 72. Find the first 5 terms of the progression. Here, without writing S2, again I can take as first term and second term and write down an equation. What's the first term? A. What's the second term? AR. Now, look at carefully these two equations. I can take A out and rewrite this as 9 is equal to 8 times 1 plus R. That's my first equation. Now look at this one. I can take AR to the power 3. When I take AR to the power 3, it's 1 plus R. That's equal to minus 72. That's my second equation. Now divide. Second equation divide by the first one. Minus 72 divide by 9. You get minus 8. A get cancelled out and 1 plus R get cancelled out. So I'm getting R to the power 3. How am I getting minus 8? Minus 2 to the power 3 is R to the power 3. Same power, you can write R equals minus 2. Now we found R equals minus 2. Substitute to equation 1 and find out A. 9 equals 8 times 1 minus 2. 1 minus 2 is minus 1. So A becomes minus 9. Now we need to find out first 5 terms starting with minus 9. So we'll write down minus 9. Minus 9 times minus 2. You get plus 18. Plus 18 times minus 2, 36. That's minus. Minus 36 times minus 2, you get plus 72. Plus 72 multiplied by 2, you get 144. That's negative. So these are the 5 terms in this sequence. Example number 2. The first 3 terms of a geometric progression are respectively x plus 2, x plus 12 and x plus 42. Find the first term and the common ratio. This is geometric progression. The common ratios are equal. How can we find out the common ratio? If you take this one, x plus 12 divide by x plus 2. Or if you take this term, that's x plus 42 over x plus 12. Now, this is geometric progression. Those are equal. Now, cross multiply and Solve for x. X plus 12 squared is equal to x plus 42 times x plus 2. Expand brackets. I get x squared, double of this, 24x, 12 times 12, 144. This side, when you do FOIL or rainbow method, you get x squared plus 2x plus 42x plus 2 times 42, I get 84. Now, x squared get cancelled out. 2 plus 42, 44. When you subtract 24, what you get? 44 minus 24, x is equal to 144 minus 84. When you subtract, you get 60 equals 20x. So what's x? X equals 3. So find the first term. So what's the first term? First term is 3 plus 2. That's 5. What's the common ratio? We need to find out the second term to get the common ratio. When x equals 3, what's the second term? 3 plus 12, 15. The next term is 15. So what's the ratio? 15 divided by 5. That's equal to 3. Exercise 16.5. Question number 1. The sum of the second and third terms of a geometric progression is 21. Second and third. How can I write down? 21 is equal to second term. What is second term? T2. T2 I can write AR plus third term AR squared. I can take AR out and write down this as 1 plus R. That's my first equation. Sum of the fifth term. Fifth term is AR 4. Sixth term AR 5 is equal to 168. I can take AR to the power 4. When I take AR to the power 4, I get 1 plus R. That's my second equation. Now divide. 2 by 1, 168 divided by 21 is equal to A get cancelled out and R to the power 4 divided by R, I get R to the power 3 and 1 plus R get cancelled out. So this is 8. R to the power 3 is 8. So what's the R? I can write 8 as 2 to the power 3. R is equal to 2. Now we need to find out A. We'll take the first equation. 21 equals A times 2. 2A, 1 plus 2, you get 3. So 6A equals 21. A equals 21 divided by 6. Divided by 3, 7 over 2, or you can write 3.5. So first term is 3.5, or I'll write 7 over 2 and the ratio is 2. Now we'll write down the first 5 terms starting with 7 over 2. Multiply by 2, you get 7. 7 multiplied by 2, 14. 14 multiplied by 2, 28. 28 multiplied by 2, 56. So these are the 5 terms for this sequence. Question number 2. The first 3 terms of a geometric progression are 4x plus 3 and x plus 27. Find the value of x. This is a geometric progression, so the ratios are the same. If you take x plus 3 and 4, that's the ratio. If you take this one, this is the ratio. The ratios are equal. Cross multiply and solve for x. X plus 3 squared is equal to 4 times x plus 27, and x plus 3 squared, you get x squared plus double of this 6x plus 9 is equal to 4x plus 4 times 7, 28, 4 times 2, 8, plus 2, 10. Now you get a quadratic equation. Take all terms to one side, x squared, 6x and 4x, you get 2x. 9 minus 108. 108 minus 9, 99. So this is minus 99 is equal to 0. Factors of 99 to get plus 2. We'll see what are the factors. When you divide by 3, you get 33. Divide by 3, you get 11. So 11 and 9. So factors you can write 11 and 9. Plus 2 is there, that means this is plus and this is minus. So when you solve the equation, product is 0, you can write this one is 0 or x minus 9 equals 0. So you get a negative answer here, you get a positive answer here. Now, nothing mentioned about positive or negative, you can take both the answers. So if this is minus 11, you need to write down the first 4 terms. So we'll take the first one, x equals minus 11. If x equals minus 11, what's the sequence? You get 4 minus 11 plus 3 minus 8. Minus 11 plus 27. You get 16. That's the first 3 terms. But we need first 4 terms. So what's the ratio? We need to find out the ratio as well. What's the ratio here? R equals minus 8 divided by 4. You get minus 2. So 16 multiplied by minus 2, you get 32. That's minus 32. So those are the 4 terms. Now we'll take the next one. If x equals 9, what are the terms? 4, 9 plus 3, 12. 9 plus 27, 36. So that's the sequence. So what's the ratio there? Ratio becomes 12 divided by 4. That's 3. So what's the next term? 36 times 3. You get 108. So these are the 4 terms when x equals 9. Question number 3. The sum of the first n terms of a progression is given by 4 times 3 to the power n minus 1. Show that this sequence is a geometric progression. So Sn is given 4, 3 to the power n minus 1. Show that this is geometric. Now if we can write down the formula in this form, we know that that's a geometric sum. How can we rewrite? Now this is the numerator. If I can write this one as 3 minus 1, what should I do? 3 minus 1 is 2. I put extra 2 there. So how can I get rid of that 2? I can multiply this by 2 again. So what happens? I get 4 times 2, 8. 3 to the power n minus 1 over 3 minus 1. Now look at the formula. What's the A value? A is 8 and R is 3. So this is a geometric sequence progression because you get the sum in this form. So what's the geometric sequence? The first term is 8 and the ratio is 3. And then you are asked to find the first 4 terms. How can we find out the first 4 terms? First 4 terms starting from 8. 8 times 3, 24. 24 times 3, 72. Then 72 times 3, 216. So these are the 4 terms for this geometric progression. Now I'll show you another method to do this question. If you can't figure out this one, you can use this method as well. But we know Sn formula. So Sn is given for 3 to the power n minus 1. Now we need to find out the terms and see whether it's a geometric progression. So when n equals 1, what you get? 3 to the power 1 is 3, 3 minus 1, 2. So you get 8. That means S1 means first term is 8. When you take n equals 2, what happens? S2 equals 4 times 3 to the power 2 is 9, 9 minus 1, 8. 8 times 4, 32. What is S2 means? The sum of first and the second term. First term is 8. Sum of first and second is 32. So what's the second term? So second term is 32 minus 8. What's that? 24. So we found first term is 8, second term is 24. Now we'll try the third term also. N equals 3. S3 equals 4 times 3 to the power 3 minus 1. 3 to the power 3 is 27. 27 minus 1, 26. 4 times 26. What's the answer? 104. What's S3 means? Sum of first 3 terms is 104. But we know sum of 2 terms is 32. So when you subtract 32 from 104, we get the third term. So what's the third term? 104 minus 32. That's 72. Now we have first term 8, second term 24 and the third term 72. How can we decide whether it's a geometric? Look at the ratio. Here when you take first 2, what's the ratio? Ratio is 24 over 8. That's 3. Now take second and third. What's the ratio? 72 divided by 24. That's also, you get 3. Now you get same ratio. So that means this is a geometric progression and we found 3 terms and you can find out the 4th term. So you get the same answer as before. Question number 4. The first 3 terms of a geometric progression are such that they are the first, third and 6th terms of an arithmetic progression. The 5th term of the arithmetic progression is 15. Find the first 4 terms of the geometric progression. This is a combination of geometric and arithmetic, because for the exam you are getting one full question, arithmetic and geometric. Now recently they look at more marks for arithmetic than geometric. Look at this one, the first three terms of a geometric are the first, third and sixth term of an arithmetic. The fifth term of the arithmetic progression is 15. First three terms of a geometric progression. First term is A, second term is AR, third term is AR squared. Those are the first term of the arithmetic, third term and sixth term of the arithmetic sequence. The fifth term of the arithmetic progression is 15. So fifth term, how can we write down? In this one, I can write first term is A. How can I write third term in the arithmetic sequence? T3 is, use the arithmetic formula now. A plus n minus 1d. If this is 3, that's 2d. That's equal to AR. That's the third term. If it's sixth term, what is T6? A plus 5d. That's equal to AR squared. And also, fifth term is given. T5 is A plus 4d. That's equal to 15. Now we can take this equation and rewrite A. So what is A here? A is equal to 15 minus 4d. Now what's the first term of the geometric sequence? That's 15 minus 4d. What's the second term? Second term is A plus 2d. That's 15. We can substitute A as 15 minus 4d. 15 minus 4d plus 2d. When you simplify, you get 15 minus 2d. That's our second term in terms of d. What's the third term? Third term is A plus 5d. What is A plus 5d means? A is 15 minus 4d plus 5d. You get 15 plus d. We know these are three consecutive terms of a geometric progression. So the ratios are equal. So I can write 15 minus 2d over 15 minus 4d is equal to 15 plus d. Now here, this term divided by this, so 15 minus 2d. Now cross multiply and you can find out d. I can write 15 minus 2d squared is equal to 15 plus d times 15 minus 4d. Now expand brackets. I can write 15 squared is 225. 2 times this, 30. 30 times 2, 60d plus 4d squared is equal to, again, rainbow method, 225 minus 60d plus 15d minus 4d squared. Here, lot of terms get cancelled out. 225, 60d, 4d squared plus 4d squared, 8d squared. And I can take this one to this side. minus 15d equals 0. D is common, take it out. So product is 0 means either d equals 0 or 8d equals 15. So d equals 15 divided by 8. Now we found d equals 15 over 8. So what was the question? Question is to find out the first 4 terms of the geometric progression. Now what's the first term? A. You can substitute A. You can substitute D to this formula. What is A? 15 minus 4D and find out A value. So D equals 15 over 8. Substitute here 15 over 8. 4 times 2. Then I can write, this is 15, take it out. 1 minus half. 1 I can write 2 over 2. Now simplify, I get 15 and into half. So 15 times half is 7.5. Or I can write 15 over 2. So the first term I found, and how can I find out R value? I need to use this one to find out R. We can find out this term. What's this term? The second term, 15 minus 2d. 15 minus 2d is 15 minus 2 times d, 15 over 8. What's the answer? 15, 1 minus 1 over 4. I can write 4 over 4. 4 minus 1, 3. So 15 times 3 over 4. What's the value? 45 over 4. That's equal to the second term. So what is second term? According to this given information, the second term is AR. So that's equal to AR. A we found, what's the A value? We found A as 15 over 2. R. Now you can find R. 15 times 3 and 2 times 2. So R you get 3 over 2. We know A equals 15 over 8. 15 over 2, not 15 over 8, 15 over 2, and R is 3 over 2. You can find out the first 4 terms. What are the first 4 terms of the geometric progression? 15 over 2 multiplied by 3 over 2. You get 45 over 4. Then 45 over 4 multiplied by 3 over 2 again. You get 3 times 5, 15. 3 times 4, 12 plus 1, 13 over 8. So these are the 3 terms and you need another one. 135 over 8 times 3 over 2. What's the fourth term? 3 times 5, 15 and 3 times 3, 9 plus 1, 10. 3 times 1, 3 plus 1, 4 over 16. So those are the 4 terms of the geometric progression. Look at question number 5. The nth term of a progression is this. Nth term, now we have to use Tn. Tn is given 3 into 2 to the power n plus 1. Show that this is a geometric progression. So when n equals 1, you can find out the first term. 3, 2 to the power 2, 4 times 3, 12. When n equals 2, I can find out the second term. 3, 2 to the power 2 plus 1 is 3, 2 to the power 3 is 8, 8 times 3, 24. What's the third term? Third term is plug 3 for n. You get 4, 16 times 3, 48. So the first term is 12, second term is 24, third term is 48. Is this a geometric progression? We'll look at the ratio. 24 divided by 12 is 2. 48 divided by 24, you get 2. You get same ratio. That means it's a geometric progression. Find the first term and the common ratio of the progression. We found out the first term. What's the first term? First term is 12. How can we find out the common ratio? Here, we use the terms. So what's the common ratio? Common ratio is 2 for this geometric progression. Question number 6. The first term of a geometric progression is 9. The sum of the first 3 terms of the progression is 7. Now, how can we write down sum of first 3 terms? I can write first term is A, first term is A, second term is AR, third term is AR square. That's equal to 7. And take A out from this, I get 1 plus R squared is equal to 7. But we know A is 9. Substitute 9. 9 plus 9R plus 9R squared is equal to 7. Now take all terms to one side. 9R squared plus 9R plus 2 is equal to 0. Now we need to factorize. Use cross method. Factors of 2, 2 and 1. Factors of 9, 3 and 3. 3 times 2, 6. 6 and 3R, you are getting plus 9R. So that means the factors are 3R plus 2 and 3R plus 1. So when you equate to 0, R is minus 2 over 3 or R is minus 1 over 3. Because when you equate to 0, take 1 to the other side, you get these two R values. So here we showed that there are 2 such geometric progressions. Write the first 4 terms of each progression. Now we found out the R value. Now we'll substitute. When R equals minus 2 over 3, A is 9. Starting from 9. 9 times minus 2/3. 3 times 3, you get minus 6. Minus 6 times minus 2/3. You get plus 4. And we need another term. 4 times minus 2/3, you get minus 8 over 3. Those are the 4 terms of first sequence. What's the other one? Now R equals minus 1/3. Starting from 9. 9 times minus 1/3, you get minus 3. Minus 3 multiplied by minus 1/3, you get plus 1. Plus 1 multiplied by minus 1/3, you get minus 1 over 3. So these are the first 4 terms of the other sequence. In this lesson, we covered geometric progressions and What's the nth term formula of a geometric? And the sum of first n terms. So remember the formula, and when r equals less than 1, we use one formula, and r equals greater than 1, we use another formula. Remember all these formulae to solve problems related to geometric progression.